Hello guys, welcome back once again. So today is day 23 and we are going to cover ACL, that is access control list. First of all, I'm very apologize for that because I have not recorded any of the video from so long because I was quite busy in some of the projects and they were really crucial to my company, so I had to do it and hardly get time to record any of the video. It's still I find some of the time, and let's see what is the access control list. So first of all, it is very important to understand that sometimes what is happening that we are having some of the computers let me take just a very easy or simple architecture that let's say in your company you are having the two departments, right? You have one switch here, not switch, in fact let's say one router. You have one router here and another router, this one, right? And this, let's say this is our router 1 and this is our router 2. So what I'm doing, I'm just dividing this one in the two departments. Okay, so let's say this is our finance department and another one is, let's say, HR. Okay, HR or marketing, let's say marketing. Okay, so this is our marketing department. Obviously in every of them it might be some of the computers, so let's connect a switch for more number of computers, and from there they can be having multiple computers, but for the simplicity I'm just creating two of the computers. Okay, that PC1 and PC2 on this finance, and similarly this PC1 and PC2 in the marketing. Okay, there are two computers for example as of now. Now just try to understand that in your organization it might be a requirement that the PC1, or you can say for the, if you take the real life example, let's assume that this is lead, this is finance lead, and let's say here this is our PC2, that is the lead of the marketing. So this lead may need some information from the finance, right? So in that case what we want to do, that PC2 can reach to other department computers, or in fact we can say the lead, or if the requirement is there then it can reach to other employees or members as well. But while who is the non-lead, who are just normal members, they need not to contact the other department. So we don't want to give them access to outside of our department. It means they can communicate to the lead, or if any of other computers is there, so then this PC1, because this is a normal user, then he can communicate to this, but cannot communicate to the other departments. So this is a type of we are controlling the access that PC1 or some specific user that cannot communicate to other departments. Or we can also assign the privileges, like if you are having that internet, right? So that normal employees cannot access our internet, while our managers, let's say here manager is also there or lead are there, they can access the internet. So that also we can create the policies and we can apply on these routers interfaces in any of the interfaces as per the requirement, and then that access will be allow or denied. There are the two terminologies in the access list, that is the permit and deny. So based on the other different rules, it permits the traffic or deny the traffic. So let's just explore more. So I hope you have got some basic idea that what access control list is going to do, but how we configure it in the routers, in the Cisco routers, and actually how it works, let's know more about the access control list. So this is just an overview for this one, and oh, let's just switched it where it is going. Yeah, Here it is. So let me change the color first. Let me take the red color. It will be visible, otherwise, yeah. So the first thing is network administrators must figure out how to deny unwanted access to the network while allowing internal users appropriate access to the necessary services. So it is similar to like what I have just explained, that this is the job of network administrator, who just creates these access list based on the requirement or the policy of the company, that who or which services can be accessed by specific users. So this is basically done by our access control list. What other jobs is done? Although security tools such as passwords, callback, equipments, and physical security devices are helpful. So this is a very good thing, and we should understand this. What it is saying, that you might be thinking that the same thing, right? I just told you that we want that a specific user cannot access the other department, right? That's what I said. So you might be thinking the same thing can be done via the password as well, right? We can set the password that will be known only to the leads or the managers who can access. So obviously we can set these passwords as well, but this password is actually in the application layer, right? If you open the Facebook, let's suppose you want to open the Facebook, then you write facebook.com, then a page opens, and then you enter the password and you just go inside of that Facebook. What if that, if you don't want to open that page, means that's another level of security, right? It's like if first thing, obviously you can do that thing that if I know the password, then only I can log in. Sorry. But what if that if any user is not authorized for that one, then even if he open that facebook.com, if that page is not opening, right? If that Facebook page is not opening, then how can he enter the password? Or he can enter the username and password, right? So this is the first level of, in fact, the layer 3 security, that we just block the URL. You are not allowed to open the facebook.com, then even if you know the password, then you cannot open, right? So it is like another level of security. That's what it is talking about. Although security tools such as passwords, callback, equipment, and physical security devices are helpful, we do that, but we can put one more level of security, that is the doing via access control list. Even if you know the passwords and you have the physical security connectivity, like you have got the LAN cable or something, but it's still you're not allowed via our access control list to access that specific computers or server or other departments, right? So router provide the basic traffic filtering capabilities. So this is like we can filter the traffic based on the services. Like if you want to block FTP service only, then we can block FTP. Remaining our HTTP service will be running very fine. So that is also having the feature. We can block the traffic based on the type of the traffic, that how it is actually. Another one is an ACL is sequential list of permit or deny statement that applies to addresses or upper layer protocol. So this is really too good to understand, because this is the base of our we should say access control list. If you do not understand this, it is really difficult. So this is saying that an ACL is a sequential list of permit or deny statements, right? So it is like we can say that let's suppose your IP address is 192.168.1.1. okay, so it is creating a list and it is saying that please, if it is having 192.168.1.1, please permit it, right? Similarly, if any other computer is there, 192.168 1.2 and I say that deny it, don't allow that traffic. So whenever we are hitting any traffic or we were requesting the ping, it goes to the router checks that access list. It says okay, it is source address is this one, and it is saying that permit the traffic, so it forwards the appropriate interface where it wants to go. But if is checks and the rule is hit, this statement is checks okay, this is the deny, it means that the traffic will not be go forward. You have requested to ping some server, but it is checking okay, this source address is not allowed to ping that address, then it will just discard the traffic and deny it. So this is what is happening in the ACL. Don't worry, we will learn more on the ACL. We will learn standard and extended ACLs as means to control network traffic and how ACLs are used to as a part of security solution. So there are two types of ACL. That is, first is standard ACL and another is extended ACL. So standard is the little old one. It is not having some features capability like destination address, source address, or protocol bifurcation. So it is having just basic, that it is having just source address is just checks that or destination address is checks that okay, only allow or deny. But in extended ACL we are having the capability of the ports as well, port number blocking. It means that we can deny or permit the traffic based on the services mean that either it is FTP service or STTP service, or it is that is 443, that HTTPS, correct? So we can just allow or deny the traffic. So if it is like a bank website and we don't want anyone to establish an unsecure connection, then we can block this port and allow only HTTPS port number. So we can just block the port number 80, that is HTTP, and allow that 443. HTTPS is having 443 port number, right? So that's what we can do with the extended ACL. So we will learn both of them, not to worry. So let's see some more. The router examines each packet to determine whether to forward or drop it based on the whether to forward or drop it based on the conditions specified in ACL, right? So we are having some list of the ACL. Is just whenever any traffic is coming, it just checks that AC access control list and it checks it okay, the condition is to permit it or deny it. So based on that permit or deny statement, it takes the decision whether to forward it or drop it. So some ACL decision points are like IP source address. We can set an IP source address, IP destination address, UDP or TCP protocols number, upper layer protocols like port numbers. That's what we discussed, the 80 and 443 or something. There are a lot of transport layer protocols, right? So that's based on those we can bifurcate the services and the traffic, and we can just specify whether you want to forward that traffic or not. Okay, so let's learn more about the access control list, that what it is actually, right? So let's learn that what actually it is and how it is working, right? Then only we can understand the functionality of this one. So an ACL is a group of statements that define whether packets are accepted or rejected coming into an accepted or rejected. I think I read the 2 times, or it is written 2 times. Okay, anyways, or leaving an interface, leaving an interface. Yeah, it is I think written 2 times, or leaving an interface, or it's written 2 times. I'm sorry, I just copied from somewhere I think, and so it happens like, because I just not take so much time to prepare these slides. I think when I don't remember from where I copied. I'm sorry for that. Anyways, so that's not too important. We have discussed too much on that one. So next is our ACL statement operate in sequential logical order, top to down. It is very important thing. Why it is very important? Let's suppose you have given one rule that please 192.168.1.1, okay, and specify that for the port number 80 please uh, allow, okay, and that's we see as a permit, right? It means that from this source, then if the port number is 80 and from this source, then the rule says the permit. Another condition you have given once again, right? You are creating an access control list, and this time you have given the same statements for the same port number, and this time you have deny the traffic, right? And obviously they will be having some more other IPs and all for the rules, but and at the top also you may have list, or let's say for a simplicity, just say we are having just two rules only, right? We are having just two rules. So what it is doing actually is just start checking the rules from the top to bottom. So it's just checks the first rule. It is saying that's 192.168.1.1 port number 80 permit. When it is saying finds the match for this specific IP address and specific port number and finds that it is has permitted, it will not check the next rule and simply stop looking at the access control list. Just find the match, permit the traffic, and forget it. Whether in the next line, although you have said please deny it, so it will not block the traffic, it will just allow, because it has find the match in the first line. It is stopped looking on the control list and just moved on, right? Forward the traffic. While if what you do, if you give this later on state on the first, like if you have given let's suppose 192.168, I think I have missed the IP here, 168.1.1 port number 80, and if you give the statement first deny first, and then you have given as 192.168 and then 1.1 again, and then port 80, and next time you have given as a permit, right? So if this is your access control list this time, and then what is going to do, it just find from the again top to bottom like this one. So it just first checks this line and it finds a match, that is source IP address, destination IP address is saying there's deny. So it will just drop the traffic, it will not forward it, whether while you just allowed or permitted it in the next line. So it will not going to check the next line. So that's what it is saying, that ACL statements operate in sequential logical order, top to down. Oh, I explained you I think next line as well. If a condition match is true, the packet is permitted or denied, and the rest of ACL statements are not checked. That's what I was explaining right now, that whenever the first match is found, it is not going to check the next one, right? If all ACL statements are unmatched, the implicit deny any statement is placed at the end of list, by default not visible. So whenever you configure any of the access control list, and if you make a control list like let's suppose 10.10.1.0 network, this time we are taking the complete network 10.10.10.1.0, and if it is for the, let's say, any port number, not a specific port, and we just say permit, right? And we have only one statement in that access control list. Then what it is saying, that in every ACL there is a implicit deny. Implicit deny means it is automatically saying, it is not written although, but it is always applicable, that deny any, right? So if you are having any request from 10.10.2.0, right? Let's say for first let's take the example for 1.0, okay? So if the request is from this 10.10.1.0, so sorry, let's say 10.1, okay, that's a specific IP address 10.1, this is the IP, so it just checks the access control list and it finds that 10.10.10. Sorry, let's start from this again, 10.10.1.1, right? So that's matching in this network, that falls under this network, so it is checking any of the port. Okay, I just permit it. So that's allow. If I even if I take 10.10.1.2, that's also coming in that network, so that will be permitted. But what if we change the network? If you are taking that network 10.10.2.0, right? So it's just start checking that access control list is fine. There is a no match. 10.10.1.0 is allowed, but there is a no other match, right? Although we have not mentioned that don't deny the traffic, but is still there is always an statement like deny any. So if it is not matching, it will by default it will deny the traffic. So that's what it is saying, that even if you do not specify the other things, is just only permit the things which are specifically mentioned in the access control list. Remaining all which are unmatched, they are just denied. Those packets will be dropped. So that's what this is mean. Although this deny any is not mentioning, we are not mentioning, this is by default actually in the access control list by Cisco actually, right? So when the first learning how to create access control list, it is a good idea to add an implicit deny at the end of ACL to reinforce the dynamic presence of the command line. So they are saying that when you are learning, then please specify manually this deny any, so you will not be confused that why it is not denying, why it is denying this traffic, although I have not mentioned. So because there is by default deny any, implicit deny. So for your understanding, you can just give an statement that deny any, so it will be easy to understand you that why it is traffic is blocking, right guys? Okay, let's learn more about it. So there are two types of the access control list, that is standard IP ACL and that is extended IP ACL. So standard IP ACLs can filter only with the source IP address. I'm not sure whether before some time I said source and destination, both of them, or only sources, but this is the correct one. It can filter only based on the source IP addresses. It means that you can say just if you are creating a statement, so it's just have two columns like IP address 192.168.20.1 20.1, and after that one there is the next column, that is a permit or deny. That's two lines only. While if we talk about the extended IP ACLs, then they can filter based on the source IP address, destination IP address, protocol, and some other services like telnet or HTTP or whatever we just discussed, right? Different port numbers, different type of services, FTP, telnet, HTTP, a lot of services. If you search on Google that how many ports number we are having, you will get the complete list of that one, right? So this just two things is standard IP ACLs and extended IP ACLs. So, and in the standard ACLs you are having only the name you cannot give. That standard IP ACLs is having only numbers, right? We are just creating some of the access control list, so we are having just numbers only, like access control list number 10 or 11 or 15 number or 92 numbers access control list. So like that access control lists are there. Wherever if you are having the extended ACLs, so this is having the numbers as well as we can give the name as well, right? So we can create a ACL named as test or something, right? So that's what we can do with the extended ACLs. And with the standard one, we are having from 0 to 99 only numbers, and after that one, so we will see that whenever we are doing the lab. I think I will record another session or not, I'm not sure, because if it's going to quite long, then I have to record a new one, and if it is not too much time, then I will club on this one. Okay, let's see something more about this. Okay, so this is just an example, and I think this is I have taken from Cisco website. Yeah, I remember it. Yeah, so this is just quite a typical example, and I will try to do the same thing on the Cisco packet tracer. What we are going to do, we are going to take these 3 routers, and in 3 routers we are going to take 2 computers in each of them. So the first is going to be administration, another department can be sales, and another will be engineering, right? So we will take these networks for the interface configuration. So here we have taken the .1 IP address, here .2 IP address. It means that this interface will be 172.16.20.1, and this interface will be 172.16.20.2, right? So that's what it is going to happen. And same thing on the these interfaces. So this is network 172.16.10. So this is 10 dot network, this is 30, this is only changing 30, and this is 50 network, and this is 40 network, right? So that's what is the network, means they have started like that one: 10, 20, 30, 40, 50, right? And how we are creating access control list? This is the command. We go to the configuration mode, we go to the access list, and we create a number for that one, right? We just told you that not we, in fact I told you that we can create a number. So this is access list number 10, and now we are saying that permit 172.16.30.2. so we are just giving a statement that please permit this IP address, right? So here we are saying that implicit deny any, do not need to add this, discussed later, right? So this is like we don't need to add that, but it's still just for example we have added access list 10 with the same access list. We are adding one more statement in the same access list, like deny 0.0.0.0.255.255.255. It means that any other traffic will be denied. If there is a match for this, it will be allowed. If it is not a match, then it falls under this category and the complete traffic will be denied. Perfect. So I think yeah, this is also a very important thing. So you said that you just observed, right? We have just created an access control list, and that number was 10, right? Let me clear it. Erase all the yeah. So we have just created an access control list number 10, and that is having just one statement, that please permit this IP address, right? So we have just created that IP ACL, but still we have not applied anywhere. So that's what it's saying. You can define ACLs without applying them, right? We have just created it but not applied to any of the interface. However, the ACLs will have no effect until they are applied to router's interface. So we have created it that please permit that specific IP address, but it does not make any sense until and unless we apply that ACL to any of the interface, right? We said that please permit that IP address, but where you want to permit, from where the source IP address will come, and where I have to check. I have to check on this interface, I have to check on this interface, I have to check on this interface, right? On which interface I want to check, you want to check. So that's why we create an access control list, and then we apply it in any of the interface. Another thing is to out and in, right? And what is this? Out and in. So right, if it is like we have originated from it any traffic from this one, so where you want to check the traffic, you want to check the traffic which is coming inside of this one, or you want to check the traffic which is going outside of that interface. So that you have to understand very carefully, that where you want to apply that interface ACL on which interface first, and then you want to check it inside the traffic or outside the traffic. So inside means that whenever you apply the inside means from this, how this is inside, and whenever we mean that outside means this side. Perfect. So you have to be little you have to do little practice to understand actually what is in and what is out. Until I do in the lab and you don't feel it, it is really difficult for you to understand just with the words, right? So let's go what is written here. Out means the traffic that has already been routed by the routers and is leaving the interface. So if it is means out, it means that it is leaving the router interface. Very simple. It is leaving the router interface. It means that going out to the router. It's very simple, that whatever is going outside of the router, that is out. The traffic that is arriving on the interface and which will be routed to router, that is in. So it means that it is coming to the router. It is coming to the router. It means that it is in, right? Obviously, if you are inside, you are a room. If there is a room, what is the going inside of the room, that will be called in, and what is going outside of the room, that will be out. So that's not too difficult, but still you just don't do the lab, then only you get confident, else you might not. Anyways, another thing what I just missed that was this part. It is a good practice to apply the standard ACLs on the interface closest to the destination of the traffic and extended ACLs on the interface closest to the source coming later. So we will explain it, but I want to explain it right now. Why I want to explain it right now? Because I feel that this is important. So let me change the color. Which color? Let's say black. Oh, black is already too much. Let me take green. Yeah. So why it is important? Let us suppose you want to block accessing the internet to this IP address, right? You want to block this, that this user cannot access to the internet, or not to internet. Let's suppose this guy cannot contact to our administrator, right? We do want to that it cannot we can say connect to our administrator. Now what you did actually, you configure that access control list on this interface, right? On this interface, this one, this. So what is happening, that this traffic is going towards this one, and then it is going to this interface. So what it is doing actually, it is wasting the resources of our this router. The finally, because it has been allowed on this one, so it has gone to this. Further, this router has looked up a routing table and then it's forwarded to this interface, and then whenever it is reaching to that interface, then it is knowing that, oh, I have to deny it. So unnecessary, it is our wasting our resources. So it is, that's why it is saying that it is very important to configure it very close to the interface where it was. And sometimes it is very important to not to configure it too far. Sometimes what we do, we just block the network, any of them. Now it may affect the traffic of this router as well if we configure any unnecessary access control list of this interface, right? Although we have to deny any of the traffic for this router, so obviously this is in this interface we should focus on, but by default, by mistake, or by your smartness, you did on this interface. So it is because this interface is also the path to communication to this router C routers, so it may affect some of the packets, or if it is rule is something matching or mismatching, this had something happening, then it may affect that traffic as well. So it is very important to configure close to our interface. Okay, so I think now we have to switch to the lab. So but before that, we can see that how to apply it. So we have created one access list, this one, and deny this, implicit deny, and then we can go to the interface with the name on which interface, and we can just write this command IP access group 10 in. It means that I have applied access group access list number 10, and what I have configured, that is inside. Please check the traffic which is coming inside of this interface. So that's what we have to do. So rather than explaining the extended ACL right now, I will do the lab for this standard ACL first, and then we will have another session for the extended ACL. So you will be little familiar, otherwise I will go totally theory and do not take the lab actually, so it is very difficult to go completely theory and then lab at the last. So let me take the lab for this standard one, then we will go theory for the extended, and then we will do lab for the extended. Okay, so let me switch to the lab. So here I have taken one example in the packet tracer. This is similar to what we have just seen in the presentation, that earlier slides we were discussing, right? So but here there's just one change, that I have added one server over here. Okay, remaining all the topology is same, and the networks is similar to that one. This is 167.16.10.2 10.0, and the interfaces I have given .1 on this interface, right? So this will be the IP address 172.16.10.1. this .1 interface belongs to this one. I think they have some misaligned. This is .2, so .2 means that this will be, this interface will be 172.16.20.1. this will be 172.16.20.2, like that one. Again, this is 2, this .1 here, and this .2 should be this side, I think, and this .1 is actually on this interface as well, and this interface as well. I think .1 is hiding somewhere, might be, but this interface will be in this network 172.16. this network is this one 172.16.30, and this is just .1 IP. So this IP address will be 172.16.30.3. and to save the time, what I have done, I have configured these interfaces in the router. So let's just check what I have configured. So for that one, first I will check show IP interface brief. So I have configured these interfaces, gigabit Ethernet 0/0. So this interface is IP is having 172.16.10.1. this interface is 172.16.20.1 as usual, right? And I have also configured the OSPF on this. So let's see the OSPF. Show IP, what is called show IP protocols. So this is the OSPF 1 I have configured, and added the networks on this 20, 40 and 50. So 20, and this one, I think this should not be like this one. Let me show you like a show IP neighbors. No, show IP OSPF neighbors. Yeah, so right now the neighborship is like 172.16.40.1. So this is just simply I want to say that I have configured the OSPF on this interface, or I have added this network in the OSPF as well as in this OSPF. So OSPF we have already discussed, and you know how to configure it, so there's nothing new on it, right? So similarly I have configured the interfaces here. Show IP interface brief. Here there are 3 interfaces, this one, this one, and this town, like this 20 network, for 30 network on this one, and 40 network. So that IP addresses are configured. .1 this side, .1 downside as well, and here this side is .2. Similarly I have configured this interface, this router as well, and here also we can check show IP interface brief, and OSPF is also running fine, and this .8.8.8.1 is this interface, this one, and 8.8.8 IP I have given to the server, because normally Google is having that, DNS is having that IP address 8.8.8. so same thing I just try to replicate it, but that I will use in the extended ACL. Today we are not going to use this one, but still I have configured, so we'll just see what exercise we are going to do right now. And the IP addresses are configured on this what is called computers. You can just check these IP config, right? So you see that this computer is having this IP address 172.16.10.2, And the gateway I have configured 172.16.10.1. So this is as usual, we keep on configuring it. In the previous many sessions we have configured it. To save the time, I have already configured it. Okay, so that's it. And the IP addresses of the computer is mentioned here. This is 10.3, this is 30.3, this is 30.4. So that's similar to what I have label I am having. There's they are configured. So right now what I want to say that let's try to ping from this computer, this PC3 that is having the IP address of 30.3, right? So let me just show you the IP config first. So this is having 172.16.30.3. Perfect. If I want to ping this computer outside of this one, any of the computers, like ping this 10.2, right? This interface 172.16.10.2. So that's quite simple, and it is pinging. Even if I want to ping .3, then also it will be working very fine, right? Correct. So now let's say that this 30.3, this 30.3 is a normal computer, and I am administrator, and I don't want this PC3 to communicate to the outside network, because this is the network. It can communicate to this 30.4. that is okay. If it we ping that 30.4, it should be able to ping, even it is pinging to all of the computers. But now I want to restrict access on this computer. This computer can ping to only in this network, right? It cannot connect ping to another network. So what we are going to do, we are going to configure an ACL on this router, right? So first just enable config terminal T. Now what we are going to do, we are going to create an access list. So the command is IP access list. Let's put a question mark. Now it is showing the standard or extended. So what we are going to configure this time is standard only, right? Again we can put question mark here. Now it is showing 1 to 99 standard IP access list and word for access list name. So now we are going to from 1 to 19. So I'm just taking for example IP access list number as 10. Perfect. And if I put the question mark, it does not saying anything, so I'm just press enter. So now this is inside our standard access list of 10. Perfect. Now what I am going to do it, I am going to block this 172.16.30.3. so what we are going to do, let me put the question mark. What is options we're having? That permit, deny, remark, etc. right? So what we are going to do, permit, then put the question mark. It is showing as address to match, any source address, host, single host. So this time I'm just blocking a single host, this host, right? So what I'm going to do, I'm going writing this 172.16.30.3. perfect. Put the question mark. Now it is asking me wildcard mask. So wildcard mask I'm putting as 255.255.2, no sorry, 0.0.0. I'm so sorry. Wildcard mask, because pose it to the subnet mask, and then again question mark. So it is saying that it will permit this IP address to, no, but I don't have to permit it, I have to deny it, right? I have to block this. So I want to deny access to deny 172.16.30.3.0.0.0. So now I just write a statement inside the access list, which was the 10, right? So now let me exit it. And now what we are going to do, we are just, let me show you that how to see the access list what we had just created. So the command is show IP access list. If you see that, then we are having one standard IP access list 10, number 10, and it is having the statement 10 deny host 172.16.30.3. Here you see that there are two things, right? There is a 110 here, another 10 here. So this 10 is name of or the number of the access list, while this 10 it means that the sequence number of the statement. You can have the multiple statements inside the single access list. Let me give one more statement inside that access list. It will clear you. Okay, so let me go it and IP access list, and I think it is showing standard 10. Yeah, that's perfect. And inside that one, now I'm giving one more statement, although there is no computer, some others, but still I'm giving permit, right? And 172.30, sorry, 172.16.30.4 4, let me see, yeah, let's say 4. So we are having that statement, and the wildcard mask we are putting as 0.0.0. Perfect. And let me exit it and show it now, that how does it show IP access list. Now if you see that this has been become a 20, right? So inside this access list 10 we are having two statements. The first statement is deny host this one, another statement is permit host this one. So if you insert the one more statement, that will come as the 30, number 30, and then it will go like that one. If you insert one more statement, that will come as 40, deny or permit host this one. So this is the sequence number of that different statements, right? There is a one access list. It is let me just explain you in the pen, it may help you, right? It's like you are having one access list, and that is access list number 10. This is list number, right? And inside this we are having the lines, right? So normally what it should be happening, 1 2 3 4 5 6 7 8 number of lines, right? Lines. So line number 1 is this statement, this one. This is line number 2. If we are giving one more statement, that is line number 3. So in even in place of giving number 1 2 3, it is giving like that one, 10 20 30 40. So that is the thing, nothing else. Clear, guys? I'm sure you guys are so smart and will understand it easily. Anyways, so we have created this access list, but still we have not applied this access list to this router, right? So even if we ping it right now, our 10.2, then it will even if I did not apply, but still it is denying the traffic. I don't know why it should not actually, because I have not. Sorry guys, actually what happened that I already created this access list 10, so it is already inbuilt. Even if I create the access list 20, then it will not. Let me show you what would happen for the practice, just to give you demo. I already put it in place that that if any access list 10, let me show you that interface, show IP interface, and this G0/0s, right? If you see it here, then you will observe that outgoing access list is inbound access list is 10. So it is that access list is already applied on this interface. So for before that one, let me go to that interface and undo it. So I'm really sorry guys, next time I will take care, because it just totally ruins the flavor of our teaching because if something is already configured, I'm really sorry for that one. But still I don't want to waste the time and explain you once again. What I will do, I will just quickly remove that one and configure it once again. Fine. So let me go to interface G0/0/0. Okay, and what we are going to do, no access no IP access group 10. Okay, and in because that is applied inside. So once we do it, so now if we check that show IP interface G0/0/0, perfect. So now if you see it that outgoing access list is not set, inbound access list is not set. So now, and if we see the access list, it exists. Let me show you. Exit, show IP access list. The access list exists, but still it is not applied to any of the interface, so we can ping that 10.2. you see, it's still pingable, right? Although we are having the access list on this router, but it is not applied, so we are able to ping. Once we apply it, now let me apply it, configure terminal. Now we go to on which interface we want to apply. So we want to apply on this interface. Why we want to apply on this interface? Because this is the nearest one, right? The traffic is originating from here, and this is the nearest one interface. If you apply it here, then obviously the switching and resources are wasted of this router, correct? So we always configure to the nearest interface. So let me go to the interface G0/0/0, and then we will configure IP access group 10, and we want to check the traffic which is going inside the router. That's why we are giving in. So there are two options, in or out, so we are going in. Perfect. So now we can try to ping it. Obviously we cannot ping now, destination host unreachable. While if we try to ping this 30.4, it will be reachable. Why it will be reachable? Because the traffic is originating and the access list exists here, so it will not allow this side, but obviously the traffic can go inside this one. So let me ping the 30.4. you see that this is reachable. While if you try to ping 10.2, 10.3 or 50.5 of any of the interface routers outside this router, that will not be reachable. Even if you can try 50.5, then also it is not reachable. So any traffic, this computer cannot go outside. While if we try to ping from this 30.4, it can ping, right? Let me ping that as well. This is PC4, and I try to ping 10.172.16.10.2, right? It is allowing the traffic because we are having the traffic allowed for this 10.2. Have we, right? Or we have not? Let me check that as well. Show IP access list. Yeah, 30.4. So we don't have anything, we just have this deny host, this one. So, and it is also showing the matches, right? How many times it hit that rule. So this is 30.4. We are having the rule for this 30.4 that please, whenever a 30.4 is coming, please allow that one. While if it is anything is IP address 10.5, 30.5, that will not be allowed. Why it will not be allowed? Because below that one there is always an implicit deny. That's also, let me show you an example, right? So let's see, this is our computer, and this is my connector here. And now let me configure the IP address on this one, and that's time I'm going to give the IP address 172.16.30.5, okay, which is totally outside of our range. We have just allowed denied 30.3, allow 30.4, and we have no information about 30.5, but still it will not be allowed. Why? Because there is an implicit deny. Whatever you have not conveyed anything, that will automatically be denied, because we don't have information. It means that is denied. That is implicit deny. Always, irrespective of whatever the rules we are having, other traffic will always be denied. So 30.1 will be the default router. Now let's try to ping from this one. ping 172.16.10.3. You see that destination host unreachable, because this comes under the uh, implicit deny. Implicit deny means uh, we are having just two rules on this one. Outside of these two lists, whatever it is, that will always be denied. No traffic will be any, you can connect any of the computer, only this 30.3, no sorry, only permit is only this one 70.4, only 30.4 can communicate outside of the world, remaining any computer, even if you mentioned it or not. If you mentioned it, then definitely the traffic will be denied, and it is not going to that implicit rule, because you see that 12 matches, it is denied from here, and if it is not, then is still that rule which is not visible here, and but still the traffic is blocked for that. So that's enough for the standard access list. There was a quite good example. I think you might have got something, because if it is very new to you, then it is little complicated as well. So not to worry, next time if you practice, then you will get it. So I will highly recommend just you to practice by yourself. Then only you will understand it. You will feel, really that how amazing it is. Just think the rules by yourself, that what you can allow, what you can deny, and just play it with it. Once you play it, you learn very well. Okay guys, so if you have any questions or doubts, please reach to me on any of the platform, like typing in the comment section, or the following me on Instagram, sending a message, or anywhere on the Facebook group if you have joined, right? So anywhere you can reach me, you can ask your doubts. I will be really happy to help you. That's I really feel, guys, sometimes they call me and they say me, sir, you taught me very well. That really helped me to crack the interview and explain it very well. So really I feel happy when someone says like that one. So that's really motivates me to do such a good job. So anyways guys, it's quite late. I'm feeling sleepy now. I will sleep. And if you are watching late as well, so you may sleep too. If not, then continue continue your day. Okay guys, see you soon in the next session with the extended ACL. Tell that bye bye. See you soon.